Good morning, students. Today we'll see about the various acid-base concept as well as ionization of acids and bases. In the last period, we have seen about the Arrhenius theory of acids and bases, lovely Brownsted concept, Lewis theory. Now, today we will see about the ionization of acids and bases. In this case, the acids and bases are classified as the strong acids and the strong bases, weak acid and weak bases. On the basis of their extent of dissociation, the strong acids and bases are almost completely dissociated in water. For example, the hydrochloric acid HCl is dissociated in water and forms the H plus and Cl minus ions. In the aqueous medium, when it dissolves in water, it gives H plus and Cl minus ions. While the base NaOH, it also dissociates the Na plus OH minus in aqueous medium. The acids and the bases, that is the strong acid and the strong base, they are almost completely dissociates in water. Typically, the strong acids are HCl, nitric acid, H2SO4, HBr, HI, while the typically strong bases are sodium hydroxide, potassium hydroxide, and the weak acids and the weak bases are the acetic acid and NH4OH. These are the strong acids. Strong acid and strong base. While the acetic acid is the weak acid and the NH4OH is a weak base. Is a weak base. Weak acid and a weak base. What is strong? On the extent of dissociation, the acids and bases are classified into the strong acids and the strong bases, while the weak acids and the weak bases. The formic acid HCOOH, HF, H2S are the examples of the weak acids, while FeOH thrice, COH twice, cuprous oxide, cuprous are the weak bases. म्हणजे याचा आयोनायझेशन क्या है? ज्या ऍसिड आणि बेसेसचं कम्प्लीटली डिसोसिएशन होतं, आयोनायझेशन होत असतं इन द वॉटर, Such acids and bases are called as the strong acids and the strong bases, and which doesn't dissociate or ionize completely in the aqueous medium. They are the weak acids and weak bases. Then the dissociation constant of weak acid and weak base. We have to see about the dissociation constant of weak acid and the weak base. The dissociation constant is nothing but the Ka, dissociation constant of weak acid and weak base. Consider the dissociation of weak acid Ha in water. It will be represents as Ha is consider it is the weak acid. It dissociates in water and it forms the H plus and A minus in the aqueous medium. When it dissociates into water, it represents like this way, H plus and A minus. The equilibrium constant called the acid dissociation constant for this equilibrium Ka is by applying the law of mass action, molar concentration of H plus into molar concentration of A minus divided by the total molar concentration of H. This is the dissociation constant. Similarly, at the dissociation constant of the weak base, that here we will consider that is the BOH is the dissociation constant. The BOH is the weak base. At that time, it will be dissociates in the B plus OH minus in the aqueous medium. The dissociation constant weak base by applying the law of mass action, molar concentration of B plus into the molar concentration of OH minus, it gives divided by the total molar concentration of BOH. This is the dissociation constant of weak base and the weak acid and the weak base. Thus, the dissociation constant of weak acid and the weak base is defined as the equilibrium constant for the dissociation equilibrium of weak acid and weak base is this Ka and Kb. म्हणजे या ठिकाणी आपल्याला डिसोसिएशन कॉन्स्टंट हा weak acid and weak base च्या बाबतीमध्ये suppose for example we have taken the weak acid, that is HF is the weak acid and while BOH is the weak base, then the dissociation of weak acid HA in the water, it will represent like this way. HA gives the H plus plus A minus and in the aqueous medium, and the dissociation constant Ka is equal to the at the equilibrium position the molar concentration of H plus into the molar concentration of A minus divided by HA concentration of HA. Similarly, the dissociation of the weak base, that is the BOH, it represents like this way. BOH gives the B plus and OH minus aqueous medium, and the dissociation constant Kb is equal to molar concentration B plus into OH minus divided by molar concentration of BOH. Thus, the dissociation constant of the weak acid and the weak base is defined as the equilibrium constant for the dissociation equilibrium of weak acid and the weak base. Then we will see about the Oswald dilution. Oswald dilution law. What is the Oswald dilution? The Arrhenius concept of acids and bases are represented respectively by the scientist Oswald in the form of the dilution law. For weak acid, Oswald dilution law for weak acid, it gives the for weak acid according to the Arrhenius concept. What do you mean by the acid? Acid is the substance which contains the hydrogen and gives the H plus ions in the aqueous medium or in the aqueous solution. According to the Arrhenius concept, the acid is this. For the weak acids, consider the equilibrium of the weak acid Ha that exists in the solution partly as undissociated species Ha and partly H plus and A minus ions. Then the weak acid Ha gives the H plus A minus in the aqueous condition or aqueous solution. And the dissociation constant for this weak acid Ha gives the Ka is equal to concentration of H plus into molar concentration of A minus divided by molar concentration of Ha. This is the dissociation constant for the weak acid. Thus, the equilibrium, the Ha amount of, suppose that the 1 mole of the solution, 1 mole of acid, weak acid Ha is initially present in V volume. Initial volume is V dm2. Then at the equilibrium, the fraction dissociated would be at the equilibrium position, the fraction dissociated would be alpha, and the fraction of an acid that remains undissociated at equilibrium, that is 1 minus alpha. Then at the equilibrium position, the Ha is equal to one minus alpha by V, and mole per dm2, and H plus is equal to A minus is equal to alpha by H plus is equal to A minus is equal to alpha by. बड़ी याची वैल्यू क्या है? If C is the initial concentration of an acid in mole dm3 and V is the volume in the dm3 mole, dm3 per mole, then the C is equal to 1 by V. Then C is equal to 1 by V. If C is the initial concentration and the volume is V, then C is equal to 1 by V. Then replacing 1 by V into this equation. Before that, substitute these values into the equation 1. याच्यामध्ये क्या या व्हॅल्यू जी आहे h व्हॅल्यू आणि h व्हॅल्यू पुट करा. That is h is equal to alpha by v. Then a is equal to alpha by v. Then h is equal to 1 minus alpha by V. Then by putting or by calculating that we will get that alpha square by 1 minus alpha. This will be the value. Then if the C is the initial concentration and the V is the volume, then the C is equal to 1 by V. Then instead of 1 by V, we have to put this value into this equation. Then alpha square K is equal to काय येऊ लागले आपल्याला K is equal to alpha square by 1 minus alpha. Alpha square मग या ठिकाणी आपल्याला काय K is equal to alpha square C by 1 minus alpha. Then for the weak acid HA is very small or 1 minus alpha is nearly equal to 1. Then the equation will becomes the K is equal to 1 alpha square C. C is equal to under alpha K by V. That will be the equation for the Oswald dilution law for the weak acid. Okay, we will continue for the weak base in the next